As the Artemis mission continues to push the boundaries of mankind's space exploration capabilities, there is a growing need to test technologies that will build a future infrastructure for sustained human presence on the Moon and Mars. Our team, Project Swarm, is comprised of students from the Georgia Institute of Technology who aim to solve this growing issue. We're proud to introduce our self-sustaining space vehicle for the NASA RASC-AL Competition's request for proposals under the AI-powered self-replicating probes and evolutionary approach subtopic that will address this growing need in space exploration. Acting as a testbed for both AI enablement and in-situ resource utilization and manufacturing, our probe vehicle will survey asteroid belts for the vehicle's self-sustainment and conduct NASA missions requiring the exploration of asteroid belts. Designed to use the human launch system created by SpaceX as its launch vehicle, this AI-enabled self-replicating probe will journey to the asteroid belts. While navigating to this asteroid belt's interior, the probe vehicle will make initial surveys of the asteroid belts until it can rendezvous with Aethra, an M-class asteroid whose orbit crosses with Mars's. This initial survey will allow the probe to gather data on potential landing sites on asteroids suitable for materials gathering after the probe eventually leaves Aethra. Once our main probe vehicle reaches Aethra, our probe vehicle will improve itself by constructing 3 microsatellite scout probes that will detect asteroids with the highest probabilities of containing resources needed by the main probe vehicle. The main probe will land onto one of these favorable asteroids and employ swarm robot vehicles to collect resources on the asteroid and deliver them to the main vehicle. These swarm robots are reproducible through the manufacturing hardware on the main probe vehicle. This interplay between the main probe and swarm robots illustrate a hive and swarm of insects relationship. Through this relationship, the main hive vehicle's viability for long-term sustainment increases as it is sequestered from the potential dangers of traversing and resource gathering on foreign asteroids, with those responsibilities being delegated to the repairable and reproducible swarm robots. Once the main hive vehicle gathers enough resources to launch from its current asteroid, the hive vehicle repeats the process of scout probe surveying and swarm robot resource gathering for the hive vehicle's long-term sustainment and mission operations in space. We at Project Swarm continue to follow in the footsteps of those who came before in pushing the boundaries of space exploration through our vehicle design so that humanity comes closer to living amongst the stars.